basically the main problem with number 53 is the fact that they give you measurements in millimeters, but they ask you for the volume in meters, cubic meters. So in this, they want you to find the volume of a penny. A penny is a cylinder. So the volume formula for a cylinder is technically B times H, where B is the area of the base, H is the height of the solid itself. Since the base shape on a penny is circular, we can use pi r squared for the base. And then it's just a matter of plugging in our values here. So our radius for the penny was given as 9.53 millimeters. And now, here's what I'm going to do, though. I'm going to convert from millimeters into meters. And so 1 millimeter is equal to how many meters? It's 1 times 10 to the what? How many millimeters in 1 meter?
1,000.
1,000, right? So if we kind of go the other way around, so divide both sides by 1,000, we get 1 millimeter is equal to, and so it's just going to be 10 to the minus 3 meters. So if we think of this conversion right here, anytime we write 9.53 millimeters is equivalent to 9.53 times 10 to the minus 3rd meters. So I'm just going to convert this into meters here, square it, multiply by h, the height of this penny, is given as 1.55 meters. So 1.55 times 10 to the, again, we'll convert it into, or out of millimeters and into meters. And so here's our calculation. And so all you have to do is calculate this, and it'll give you your solution. And so if you take, so if we take pi times the quantity 9.53, again, our scientific notation button is the EE button. So e to the minus 3 gives us times 10 to the power of negative 3. We're squaring that entire quantity and then multiplying it by 1.55 e to the minus 3. I have decimals in my entry, so it'll display as a decimal, which is what I would want anyway. And so my solution winds up being 4.4225. Again, I think I did it to 4 decimals, times 10 to the minus 7. And so that would be your answer in terms of meters. Right now, if you calculated this whole thing in terms of millimeters, right? And so let's say you got your answer, because a lot of you said you got this number right. Oops. And then what did you get for your number here? You remember? Was it 10 to the...
I never got the power. Just got that power.
Okay, so if you typed in your answer without converting it, this is what you got, right? Times 10 to the second, I guess. If you were looking to put it into the scientific notation, right? Right, and you guys tried this and it didn't work for you.
Yeah.
And then once you identify that, you have to convert. So this would be in millimeters cubed, whereas this one is meters cubed. In order to convert, you could either convert before you calculate. If you're going to convert afterward, it's based on the same idea of similarity that I just talked about. Single dimensions would be converted with a ratio of 10 to the minus 3. But if you're doing volume, volume is how many dimensions?
Volume?
Yeah. Volume is 3 dimensions, right?
Yeah.
So what you're going to have to do on this is instead of multiplying that whole number by negative 3 times 10 to the negative 3, you're going to multiply times 10 to the negative 3 for each dimension. So you're going to cube it. So if we took this number right here that we just got and we multiply by 10 to the negative 3 quantity cubed, you'll then get the correct answer. But you have to keep in mind that when you convert out, it has to be this conversion for each dimension. So you can't just multiply by 10 to the negative 3. You have to
Why do you
multiply
cube it
for
again?
each dimension.
Why do you cube it again?